Hey there, performance management students. What's up? Steve here. Today we are going to rock question ketone. I'll show you all the exam technique that you need so you can ace a question on risk and uncertainty, expected values. If you like this video, please check out my premium video library. You can access many more videos that are not in YouTube. The link is right here, also in the description. All right, guys, let's get started. Guys, I'm in the practice platform. I'm in the exam September, December 2022. This is where you can find question ketone. Now, if you have not tried this question, you need to hit pause right now, go into the practice platform, try it on your own, then come back and continue viewing the video. You'll get so much more out of it. Welcome back, team. Let us begin. We read, construct a payoff table. So guys, we've done this before. This question comes up on a regular basis. There is a standard approach to setting up our spreadsheet. I will do that momentarily. So we've got to construct a payoff table to show all the possible profit outcomes and recommend the level of production ketone should choose based on expected values. Then in part B, they want us to get the value of perfect information. What's the maximum fee we would pay the market research company? So guys, let's make quick work of this. I will move my slider over. We can read the story, see what's happening here. And we have a new company, and they make protein powder. And they think the demand will be between 3,000 and 4,000 units per month, but they are limited to the batch size of 500. So their output will be in increments of 500 units. So they're thinking about three choices. They could do 3,000, 3,500, 4,000. And any units produced that are not sold will be thrown away. So that's the challenge here of this decision. There's a cost consequence to overproduction. So guys, right off the bat, we can set up the first two columns of our spreadsheet. We are going to have production for column 1 and demand for column 2. And there will be 9 rows because there are 3 options. So I could go ahead and just do that right now. We can produce 3,000, copy pasting, 3,500, or 4,000. Now demand will be one of those. 3,000, 3,500, or 4,000. Grab these, copy, paste, paste. So far, so good. Now, we've got a variable cost per unit. We can add these figures up in the spreadsheet quickly. And then we also learn about a cleaning and inspection cost. Every batch requires a cleaning cost and inspection cost of $240. Then we also have selling and distribution costs of 90 cents for every unit that is sold. So what I'm going to do now, here's the probability. We're going to need this probability at the end And now look at this. We have elastic demand. If we lower the price, we'll sell more units. So in order to achieve sales above 3,500, we've got to drop the price. Now, team, I am going to use the power of the spreadsheet to finish this up quickly and accurately. We are going to need the units sold, which will be different than the units produced. So we can make a column for that. And the units that we sell will be the smaller of these two figures. If we produce 3,000 and demand is 4,000, we only sell 3,000. And on the other hand, if demand is 3,000 here, but we produce 4,000, we'll only sell the 3,000. We can use a cool formula to help us find the smallest figure in a range of cells. That's called the min function. So I type min, open a bracket, and just grab a range of cells, and it will return the smallest of those, saving us a lot of time and reducing the risk of a typo if we tried to just go through there and pick out the smallest one manually. Now that we have the units taken care of, we can now finish this up with a profit table. So we will now need sales in dollars. We will need then, we have the selling cost at 90 cents. Then we have the variable cost, abbreviate that variable cost. And last but not least, we have that inspection cost, the batch cost, whatever we want to call it. And there we go. I'm even going to put a price here, I've decided. That's going to save us even more time. I can cut that out of the way, park this here. I can put a price. And if we then subtract all of those costs from the sales, we will have the profit at each production and demand point. At this point, it's time to plug in the selling price. I can resize that column. It doesn't need to be that wide. We found in the story that the selling price was $35 unless they want to achieve sales of 4,000 units. So we can plug a 35 in there and just drag it down till we get to the sales of 3,500. Only putting 33 when we actually sell more than 3,500. Now, the sales then will be the product of the units and the price. And I can then just drag that formula down. It will copy that cell all the way down. The selling cost will then be equal to the units sold multiplied by negative 0.9. 90-cent selling cost. Variable cost, well, that's going to be equal to, I'm going to do a bracket. That's going to be equal to the 6.2 for materials, the 2.7 for labor, and the variable overheads of 1.35. Now I can just put a negative sign in front of that parentheses, and it will return a negative figure there. I like that. Now I need to multiply, but not by the units sold. We need to multiply by the units we produce. If we produce more than we sell, well, we still incur those costs that we then need to write off because we didn't sell them. So I dragged it down. There we go. That's the variable cost. Now, they said the inspections were $240 per batch. So I'm going to take the units that we produce, divide by the batch size of 500, and multiply by the cost per batch, 240. And again, I can drag that down. Guys, we've now got everything we need to calculate a profit. Someone tell me what we need to do. Well, you can't tell me. This is a recording. But you know what we do. We go equals sum, and we carefully grab rows F to rows I. Don't want to grab the price. That would be a mistake. Okay, we've got the profit formula. Then I can just drag that down. And I am looking good. Ladies and gentlemen, we've now produced a profit table. It's not the payoff table yet, it's the profit table. I'm going to keep working with this because it's going to save me a lot of time. To get to expected values, we now need to put in the probability, which I can abbreviate with that percentage sign. Then we can do probability multiplied by the sales. And then if I get the sum of these three items here, that would be the expected value at the production level of 3,000. So they tell us in the story that it's 0.2 over here, 0.3 for the next one, 0.5. Does all of that add up to 1? Yes, it does. So I copy it, and then I paste it down twice, bringing in the probability for each demand level, right? The probability is linked to the demand. And last but not least, well, it's not last, I multiply the profit times that probability. I grab it in the corner, drag it down. Looking good. Now it's the final thing. Now we can make a column for EV, expected value. That will be the sum then of these three. Now I'm going to give you a big spoiler, guys. I hope it doesn't ruin your day. But the result there is going to be the 70110 because they're all the same. And saving time again, I can copy that and park it right in the middle of the next one. And that did not work. Copy the formula again, copy, paste. Now it worked. And copy it again. Guys, looking great. Let's now just apply a little light formatting. I might make that bold. And these numbers are getting a bit big. I want to make sure everything is crystal clear for the marker. So I can now put some thousand separators in. And we can indicate that this is the best one, right? So we can make a note. Using expected values, the 3,500 production plan will give the highest weighted average profit. There we go, guys. That's how I would do this. Now, let's come back to this pesky word here, payoff table. In the past, going back many years before the spreadsheet, back when we had to do these things on paper, they wanted this payoff table, which is a matrix. We're going to do production here. Then we can do demand here. And demand can be 3,000, 3,500, or 4,000. Move that up one. Production can be 3,000, 3,500, 4,000. But guys, it's going to be a lot more work to do all of these calculations in these cells. So it's much better to just do all of the work in this table as I've shown. You can check everything. It's crystal clear that everything is correct. Let's do this though. Let's make sure the marker can read that. So I put that to, don't need the 0, but it's there. So at this point, I'm just going to pull in carefully equals this one equals this one equals this one. And now that I see how that works, right, we can just do this equals that one there. And I can just drag it down. And then I can grab the first item in the 4,000, which is the 11,876. I can pull that down. And let's make these headings bold. And expected value equals, this is now, I'm being redundant here. I've already answered the question above. But just for fun, we can do it this way as well. Copy, paste, paste, and we get the same numbers. Ladies and gentlemen, that is part A, an easy 13 marks if you ask me. The key to this is practicing this type of question to hone your spreadsheet skills. With a nice spreadsheet, you can save a lot of time. Let's label our work. Let's move on to part B. So this is part A. And part B is our value of perfect information type of question. I'm going to do it over here because I'm going to need the same numbers. So I can come over here. I can make a label, B. Now, what's going to happen? If we had this magic report that's going to perfectly predict the demand, well, we would then benefit from that information because if we knew that demand was 4,000, was going to be 4,000, well, I would choose the highest profit. I would choose the 85. If I knew that demand was going to be 3,500, well, I would choose the 81 and then the 710 if demand was going to be 3,000. So now we have to make a little table over here. Expected value with perfect info. I'm going to move this up one so everything remains lined up with the rows that I have already established. So now we can do this. Demand, best profit, probability times profit. So guys, demand could be 3,000, 3,500, or 4,000. If we knew that demand would be 3,000, well, we would produce 3,000 and earn that profit. If we knew demand would be 3,500, well, we would do the same. We would get the 8,795. And last but not least, if we knew that demand was 4,000, then we would get the 8,540. But we didn't pay for the report yet, so we don't know what's going to happen. We just know that there's a 0.2%. There's a 20% chance that'll happen. There's a 30% chance that will happen. And a 50% chance that that one will happen. So guys, now I can just multiply the profit by the probability. And the expected value then would be the sum of those. Use that underline sign to show the next thing that's happening is the sum. Why is it not sticking? There it is. And let's fix the formatting again here. And we've got 8131301. Now, if we subtract from that expected value without perfect info, well, then we will have this number, the 78385. Move that up one line. And then the difference is equal to this one minus this one. So 2,915.5 or 2916 would be the value of the perfect information. And there it is. That is how much we would pay for the report. Guys, there we have it, part A and part B, 16 marks earned. I hope you guys found this debrief helpful. I hope you picked up some good spreadsheet tips. If you'd like to see the next part of this question, part C, well, head over to my website. You could subscribe to my video library there. I've got so much more than you can find here in YouTube. Well, ladies and gentlemen, it's been a pleasure working with you virtually. I'm signing out now. Good luck on your upcoming PM exam.